Welcome back. In this video, we're going to jump into some Python code and get this SQLAlchemy Flask situation set up so we can start writing the actual application here. So the first thing I want to do is create our Flask app instance. This is used by Flask to store our configuration and our routes. It's really the way that Flask has this interface with our web application as a whole. It's like the root of our app. So to do that, we're going to create a new file here called app.py. And app.py is going to import this Flask class constructor from the Flask module. Then we're going to instantiate an app and pass in this __ name variable, which basically just stores like the name of the module. If the module is executed from the main program, like if this script is executed as the program itself, then the name will be main. You've probably seen that in Python code, the if __ name equals __ main. That's all it's doing here. It's just identifying where the code is being executed to the Flask constructor. Then we can create this URI string for our database. This is going to tell SQLAlchemy how to connect to our database. So like I said, it can deal with different database backends. So it's got to know, hey, we want to connect to MySQL and we want to use this PyMySQL or this PyMySQL module to do the interfacing. And that's exactly what this line of code is doing. It also tells it the credentials. So in this case, it's root password at localhost because it's running on this actual machine. And then it's going to be feed reader is the name of the database, the one we just created. So we'll put that string into this config key. And this is where the Flask SQLAlchemy module is going to pull this database URI string so it knows how to connect. So we just set that. And now we want to instantiate the actual SQLAlchemy object. I'm going to do that by creating another little submodule called db.py. And it's going to import that app object that we just created. It's also going to import from Flask SQLAlchemy this SQLAlchemy object constructor there. And it's going to instantiate one of those, passing in that app. So this Flask SQLAlchemy module has this SQLAlchemy constructor that takes in our app, and that's going to grab that configuration from the app, as well as just to sort of attach SQLAlchemy to our app to make it easier to use Flask and SQLAlchemy together. I'll save that. The next thing I'll do while I'm here is just create a little helper script to run all of this. So that's going to take that app object and that new database object. Now we're going to use a context. I'm not sure if you've used this with Python, but with creates a context block so that anything here happens within the context that's initialized here. So basically there's like a entry method and an exit method for context. And this is going to tell Flask that we're working within our app context. Flask does some magic behind the back end. It's kind of a strange way to write a web server, but it works pretty well within Flask. So when a request is called, when a context is created, it sets up a lot of things in the background that weren't set up from the script originally. And we want that setup. So we're going to execute this code inside that setup. And the code we're going to execute is this db.createAll. So within the context of our application, we want to tell the database to create all of the tables that we defined. This is going to execute the actual SQL create table commands that SQLAlchemy creates from our database model, which we're about to set up. And then, outside of that context again, we're going to just tell Flask to run the application. So now we have a way to run everything. We have our database set up to work with Flask. We have our Flask application set up, configured with our database. The only thing left to do now, I guess, is to create some models. So we'll go ahead and create a folder this time called models. And we want this folder to be a Python module. To do that, you always have to have this under init file in it. Put the init file in it. And then the first model I'm going to define will be the source model. So this model is going to represent, actually, go back to our feed.py. We know that we're going to want these attributes for our source model. So these are going to be columns in our database. We'll want some other columns, but these will be the essential columns. So let's go back to our models and we'll create this source.py file. First thing we have to do is import that DB object from the DB module. And also import datetime, because I'm going to want some datetime fields. At least one. We want to know when we added this source to our database. Because you might want to sort by newly added, or, it's a good field to have. So our model is a class, and it inherits from this db.model base class. When you inherit like this, this tells SQLAlchemy, hey, this is a database model, and then everything that I define in here is going to be a part of this database model. So the first column we're going to create is called ID. So this is going to be the primary key for our source model. Columns are always defined as instances of this db.column object, and then you tell it what type it'll be as the first parameter of the column object. So in this case, the ID is going to be an integer, and it's going to get a special flag added called primary key, which will set to true. So this is telling SQLAlchemy, hey, I'm going to create this ID column in this source table, and it's going to be an integer, and it's going to be a primary key. Hopefully that makes sense to you. Now we're going to create this title column, and it's going to be text, and it is not allowed to be null. I don't want the title to ever be null, because that's how it's going to be listed in our newsfeed. If for some reason an article doesn't have a title, we'll make our code call it untitled or something, but there will always be a title in the table in the database. Very similar to the title is going to be the subtitle. Again, I'll have it not be nullable. Now we'll want to link. You know what? Link is going to be text too, so I'm just going to copy and paste the previous one. This is going to be a link to the feed. Let's see. Right, so from the feed we get a link to the source. It's the website. So when we used NASA, their breaking news feed, for instance, there was a link to nasa.gov. And it's just nice to have associated with our feed source is some link back to the website where the feed came from, which is different from the actual feed URL itself. Like, right, there's a URL for the RSS feed. We want to keep that too, but we also want to keep a link to the website that the RSS feed came from, where it represents. So this is going to be that website link. And there's another URL that we're going to store, but this one we're going to call feed. So this is going to be a link, a URL to that actual RSS feed where the data is coming from. Now I guess I'll put a date added column. This one is going to be of type date time. And we want this to have a default value. MySQL pretty much always allows you to define a default value. And if it's a function, such as datetime.datetime.utc_now, right? So in Python, this is a function that gives you the current UTC time. So whenever our object is instantiated, we want to set the date added value to now when the object is created. Sorry. So that's the default value for this column. When we create a source, we don't have to tell it when it was added. This is going to do that for us. Now we can define our article model. And if we look back to our feed, we can see some attributes that were interesting to us. These are going to change a little bit. So this ID here is not going to be the primary key for our article. And I'll show you how that's going to work here in a second. So let's create this article.py in our models. We'll do this really similar to the previous one. First we have to import the DB. Again, we're going to want to work with date times. We'll define a class, which is an article that inherits from the models. It's got a primary key. And articles have titles. Title is not nullable, similar to before. Instead of calling this summary, I'm going to call it body, which is going to be the body of the article. That's going to imply like description or summary. We could name it either of those, but like this is shorter and it means the same in this context. And of course they're going to have links. I don't know why I'm not just copying this. So that's going to be the link to the actual article somewhere. Now the next part is we want this unique identifier. This somehow these articles always have an identifier that's unique to that source. in theory, and usually in practice, it should be unique globally. It'll be a globally unique identifier. But I don't always trust that. I'm going to say that it's going to be unique to the source. Otherwise, the source messed up, and that's their problem. I guess it's our problem once we're using their feed in our application. But we'll only assume that it's unique within the context of a specific feed. But I'm still going to call it the GUID, the globally unique identifier. I think that's what that stands for. These are going to be of type string rather than text, because I'm going to create a constraint around them, which means it is limited to 255 characters. That could be a problem. We'll address that if it happens, but I think this is going to be okay for all of the feeds I've seen. If it's not okay, you could always hash whatever identifier there is, like apply a SHA hash to it and then use that as your ID. That should have the same effect. And of course, the unique identifier should not be nullable. That wouldn't be good. Now I'm going to add a Boolean column. There are other ways to store this unread property, but the easiest and the most convenient in this context and at this stage, we may change it later, is just to have a Boolean column for whether or not this article has been read. So if it's unread, which is the default state, then this column is going to be true. And this column obviously can't be nullable. That wouldn't make much sense. So now we get to the interesting part. The articles have a relationship to the source. And the simple part of the relationship is that they have an integer column that stores the primary key for the source that they belong to. This is going to be our source ID. It's a column, it's an integer, and it's a foreign key column that specifically references this source.id. And it is not nullable. So the next part, we have the actual column defined for this table, and we've set it up to be a foreign key. The next part is more of a convenience for the ORM, for SQLAlchemy. It allows us to map things back a little bit easier in our code. So we're creating this source attribute, which is a DB relationship. To that source table, which has a back reference. I'll explain what that means after I type this. It's hard to talk and type at the same time. Okay, so what's going on here? This is all about providing an easier interface to dealing with these models. So, of course, we could just get the source ID off of the article and then look up the source if we ever needed to get the source for an article. We could do that, but SQLAlchemy allows you to define a property on the article that's just called source, and it'll do all the magic behind the scenes. It already knows that it's a foreign key, and we're telling it, hey, the source table is the relationship here, and we want a back reference, which is articles. This is interesting. So when we're on the source object, when we have a source, we've looked up a feed, it's in our database, we want to get the articles from it. This back reference will give it a property that is articles, that gives us a list of the articles, an iterable of the articles. And I'm setting it to lazy so that every time we pull the source, it doesn't pull all the articles, just an efficiency technique, a measure of efficiency in this case. And sometimes it's more efficient to actually have it pull all of it because fewer database requests, it'll grab it all in one go, or a few simple goes rather than every single time it's accessed. But in this case, I'm going to have it call the database every single time it's accessed. Easier, should be more efficient in most contexts. Now we just need to add some date fields. I'm not going to bother typing those out. We already know how this is defined. It's exactly the same in this. So that's our date added, but there's another date that we're interested in, which is date published. Right? They should usually be the same, but they're not always going to be the same. This is what the article, this is what's supplied with the article. Go back to our feed. They have this published date, and we grab this published parsed portion of it. That's what's going to go into this column. It's what the article source is advertising as being the published date. But maybe they didn't add it to their feed quickly enough. This way we get both. We get when it was added to our database and when they're saying that they published it. This is nullable. There is a case where they don't even include that published date. We'll allow it to be nullable. The last thing we need to do is create a constraint. And the constraint that I want to create on this table is a unique constraint. So I don't want any two articles to have the same source ID, so to be from the same source, and the same GUID, the identifier, the unique identifier for the source. I've already gone over that. That should always be unique. There should never be a source and a GUID pair that matches another article's source and GUID pair. That just shouldn't happen ever. So I'm going to define that as a uniqueness constraint on this table. And to do that, we create this table args tuple in our table. And in that, we can add our constraints. First constraint is this unique constraint. And then we can just fill in what columns are going to be unique. In this case, source ID and GUID, 2 columns in this constraint. And then we can name it for convenience. I'll say UC for unique constraint, source GUID. This is a tuple, so I'll put this little comma in there to make sure that this is represented as a 1-element tuple. So this should be our data model. We might need to change it later. We'll see. It's always good to be flexible when you're defining these things. But this is the data that we've established is what we're interested in from our model. And these are the relationships that we expect to happen and the constraints that we're expecting to be fulfilled within our model. So this should be everything we need. Now there was one syntax error that I accidentally introduced into this. I forgot to put an equal sign here. My bad. But otherwise, I'd like to go to the terminal and see if I can run this. Oh, I have another syntax error. Wow. Alright, so this one is in the DB file. Oh, right. I forgot to type import here. Okay, try that again. So in theory, we just created our tables. And it looks like there weren't any errors. Let's go into MySQL as our username. Use the feed reader database and show tables. It did not create our tables. And now that I'm thinking about it, I know exactly why it didn't create our tables. So let's go back to the code. I'll go to run. We didn't import the model into the application. So I defined it here, but the application doesn't know that this is a part of it and that it should import these and then create the table. So I'll do from models import article and source. Now I'll try again. Oops, wrong thing. Run. Okay, so MySQL is telling us that this key is too long. Specifically, I limited this GUID key to 255, but the encoding for this database is a larger text encoding than that. We want to change the collation on the database. I think the easiest thing to do here is just going to be go into MySQL. I'm going to drop that whole feed reader database because it did create the source table, but we didn't have the collation set to what I actually want it to be. So to do that, let's recreate that table or that database. Create database feed reader character set UTF-8. That's what we want. Collate UTF-8 general case insensitive. Oh yeah, semicolon. Okay. Now, hopefully, if we run this, it'll create the tables without any error. Looks like it, maybe. Let's Control-C to stop the server and open up MySQL again. Enter in the password, use feed reader. So now we're in our database and we should be able to say show tables. There we go. Both of our tables were created. I forget the command. I think it's show create table. Let's do the source first. Okay, yeah. So now we see the actual SQL code that was used to create the table. So you can see the ID becomes this normal integer that's not null, it's auto increment. It's also added to this primary key index here at the bottom. You can see it does this date added date time default null. That's kind of weird, but I think it's because SQLAlchemy handles the default date in Python code rather than in the database. So let's see what it has for the article. Yeah, this all looks really similar until you get down here where we have this unique key. So this is our unique index constraint. Our foreign key. Yeah, looks good. So we've got our database model all set up. We've got a basic Flask app, but we don't really have it doing anything. We've got our feed parser. Yeah, I guess the next part might be to get this feed parser inserting what it finds into the database. So the next video I'll cover how to take the results of that feed parser module we made and insert them into our database. So, bye!